Hello everyone. Today we are going to talk about faster Whisper installation on a local machine, on a local laptop basically. So faster Whisper is another variant of the OpenAI Whisper model for speech to text conversion. So basically a transcription process. So the model is based on an encoder-decoder, and faster Whisper is another implementation that employs C Translate 2. And we're going to talk about how to install this locally on a laptop today instead of doing it usually on Google Colabs. My name is Rami Kushaba and I'll be your presenter for today. So a little bit about the model. Faster Whisper is a re-implementation of OpenAI Whisper model using C Translate 2, which, as I said, is a fast inference engine for transformer models. So this implementation is reported to be 4 times faster than the original OpenAI Whisper for the same accuracy while using less memory. And the efficiency can be further improved with 8-bit quantization on both CPU and GPU. So in terms of the requirements, there isn't much actually over there. So if you look at the GitHub repo for faster Whisper, you will see they only mention that you need Python 3.8 or greater and a couple libraries for NVIDIA libraries to support the neural network implementations, which we are going to go through today. Beside that, all what you need to do is just pip install faster Whisper. So it's easy. But before actually diving into the installation, let's just talk about 2 of the important parameters of this model. So the first one is beam size. So in the faster Whisper library, okay, the beam size is a parameter used in beam search decoding. So this is a method for generating the most likely transcription. So it allows you to consider multiple possible sequences of words basically. So beam size defines the number of candidate sequences that are considered at each step. So as you can imagine, the larger the beam size, then the larger the number of sequences, potential sequences of text that you can consider for the transcription process. So basically it means that the model is doing some sort of like exploration for the potential transcription, what could be the most accurate transcription. And the more you increase the beam size, the more chances you have to find the actual most accurate transcription for the audio in hand. So how the beam search works, the model doesn't just take the highest probability word at each step. Instead, it's kind of like keeping a track of the top beam size number of possible word sequences. So if you say, for example, beam size is 5, then you keep the top 5 possible word sequences, and from that then you shortlist the most potential like candidate for transcription. So it continues to explore multiple paths until the most likely sequence emerge. Okay, so as you can imagine, higher beam size improves transcription accuracy and slow down the performance, while lower beam size improves transcription speed and reduce transcription accuracy. So it's a compromise between the two that you have to figure out yourself. What is the accepted level for your own application, for your own audio? Another parameter of interest is the condition on the previous text, and this is a very important parameter because it can slow you down terribly sometimes, depending on how large is your audio file. So this specific the condition on previous text, in models like Whisper, it controls whether the model uses the previously transcribed text as a context when transcribing the current segment of audio. So what it does, basically, it's like the model is leveraging the previously generated text as input to help predict what could be the next part of the transcription. Okay, so basically it can be particularly useful in handling ambiguous phrases, maintaining grammar, or staying consistent with names and terms. And as you can imagine, enabling this parameter adds computational overhead because the model has to process the previously transcribed text and integrate that information into the current transcription step. So you have to be careful with how you select these two parameters in the model, as we are going to show you after installation. Okay, but beside that, the remaining are the typical parameters that you find with any Whisper variant. Like, are you going to do it on CUDA or CPU, like the device type, and the compute type? Are you going to use, for example, float 32, integer 8, or float 16? What is like your selection over there? And a couple of other parameters which could be like model specific. So let's dive into the installation. And for that, you have to know that most of these Whisper kind of variants, they actually need three main components to function. So whether it's the original Whisper from OpenAI, or WhisperX, or Whisper S2T, or any other variant, the majority of them, they actually rely on the existence of three main components: FFmpeg, NVIDIA CUDA, and PyTorch. And FFmpeg is a complete cross-platform solution to record, convert, and stream audio and video. Why do we need it? Because most of these variants, they actually downsample the audio data into a lower frequency, which is typically 16,000 hertz or sample per second. So to downsample, they typically rely, the majority of them rely on FFmpeg, although you can do some downsampling with PyTorch audio, or Torch audio basically, to some extent. Then you have the NVIDIA CUDA, which is the parallel computing platform and application programming interface. So this is how, or this is what enables you to run on a GPU. And then you have PyTorch, of course, it's a machine learning library based on the Torch library. Now for the current faster Whisper is not only NVIDIA CUDA, it's actually NVIDIA cuDNN, which is a GPU accelerated library of primitives for deep neural networks. So we have to make sure that these requirements are available and installed, and then the pip install faster Whisper should be like a simple task, just like one command, hit enter, and everything should be fine. So let's install these, let's proceed with that and see how we can do that on a local laptop, because most of the available approaches, they show you how to do that in a Google Colab, and they have a TPU, GPU, and things just work over there. But in reality, when you do it on your own laptops, you will face many failures straight away that could stop you from trying many of these libraries. And the goal of today's video is just to show you how we can do it on a local laptop so you can explore on your own laptop, basically. So let's dive into the, let's say, coding side. So the first thing to do over here, I'm going to start with an Anaconda prompt. So here's my Anaconda prompt window. The first thing I need to make sure of is that, do I have a virtual environment for this already, or can I create a new one? Because I might have created one for my previous videos. So what I'm going to do, I'm going to say conda env list to show the environments that I have. I only have the base and Whisper S2T, which is another variant of the OpenAI Whisper. So right now, as we made sure we don't have an environment to hold the installation of faster Whisper, we are going to create one. So the command is conda create -n. Let's call it faster Whisper as one word. And then let's decide on the Python version, because on the website of, or on the GitHub repo of faster Whisper, they said 3.8 or above. So I'm going to just select 3.10. -y to accept the yes and no proceeding, like basically the command that asks you to continue or not. So hit enter, wait for the installation to complete, and this is typically very fast process, should finish very soon. Okay, and there you go. Now we have the virtual environment created, but we are not yet inside this virtual environment. To activate this environment, all what you need to do is rewrite this command or copy it and paste it over here. So conda activate faster Whisper. As you see, we were in the base environment, and now we are inside the faster Whisper virtual environment. So now we are ready to do our installations. The first thing that comes to my mind is FFmpeg. So I know they didn't mention it explicitly, but most of these faster Whisper, or Whisper, sorry, general libraries, they require this as a prerequisite. And sometimes they fail without telling you, like, it needs actually the ffmpeg explicitly. So let's go to ffmpeg.org. I'm running on a Windows, so I'm going to click here to download. Select the Windows version, because you can also go with Linux or Mac versions. Select this and then download the Windows exe from either of the links. I'll choose this one, Windows Builds by BTBN. So over here, I'm going to end up like selecting the one with the largest size, and this was created 14 hours ago. Click on this zip file. It's currently downloading. Okay, I've done this yesterday for another video, but I'll just show you the steps of this process. So now I am inside my downloads folder. So you can see this is the zip. I'm going to unzip it. So using 7zip, extract to this same location. I'm going to rename the file that I've extracted. I'll just delete the extra bits. Okay, and then usually cut and place it somewhere else, like in your C drive. So I've placed it over here already in my C drive. The next step is you go inside this ffmpeg, inside your C drive, inside your bin, and then copy the address over here, and then go to your environment variables. So because I'm running on Windows 11, you can actually see, you might see actually like different settings depending if you have Windows 10 or earlier versions, but for Windows 11 this is what you get. I'm running on a laptop with 32-bit gigs of RAM, and I have a GPU as well, which is the RTX 3060. So let me hit the advanced system settings. Okay, and then from here I'll go to the environment variables, path, edit, and paste it over here. So I will say new and paste it, which I have done already yesterday. So this is the C ffmpeg/bin, which is already defined over there. Close everything, accept, okay. Everything is closed. I don't need this anymore. I can even close this to clean up stuff. Okay, go back to here. But what you need to say is ffmpeg, and you can see something. Alternatively, if the installation is not correct, it will tell you can't find this ffmpeg command or something like that. But basically, as long as it gave us a message over here in different format, like you can see, it actually means it's installed. It's waiting for you to complete the command ffmpeg what. So it's there, we're 100% sure. Now we can go and focus on the installation of the NVIDIA libraries. So in the original, or in the GitHub repo of Faster Whisper, as you can see from here, okay, they mentioned specifically that they rely on what? On the existence of cuDNN version 8 for CUDA 12 and cuBLAS for CUDA 12. So this means that you actually need CUDA 12 first of all to be installed, and then you need cuDNN version 8. So I've already installed CUDA development kit, that's 12.1. So in the previous video I've actually done this on the Faster Whisper S2T installation. You can go and watch that video, but I'll just show you the steps. So basically you come here to the NVIDIA website, to the CUDA toolkit version 12.1 for this example. I'm running on Windows, an architecture which is 8664. My version of Windows is Windows 11. I need the local exe version, and then you download the file, which is 3.1 gigabyte, and then you just install it. The installation of this file is very typical. You don't have to change anything. Just click next, 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 and that's it. Follow the instructions. Nothing special about it, and you might need to restart after that. So once you have installed the CUDA version for your own PC, that's one step. You haven't finished yet. You need to come back here and install cuBLAS and cuDNN. So the cuBLAS for CUDA 12, this is only available for Linux. Like when I click on it, it will take me to the NVIDIA website again. It says download. Okay, and it's taken me somewhere else. Download now, and should take me to the final website where I can download from it. And I agree, of course, to the license agreement. However, in the versions, you can only see there is a Linux version. There isn't any Windows. And it says, oh, for Windows, come back at a later time. So we don't have it. Okay, so the NVIDIA HPC SDK for Windows will be available at a later date. So what do? Go back to the Faster Whisper website. Let's install cuDNN8 for CUDA 12. Okay, and then we resolve the remaining issues. Download cuDNN library. This one is available for Windows, so you can click on it, click on the architecture. I'll just select for version 10 because that's closest to what I have, and then download the exe. Okay, download 691 megabytes, sorry, and then install it. Just follow the commands again. Next. Nothing special about it unless you want to put it in a certain location other than the default location, which is in the program files. So install this file as well, and then you are still not yet ready. So why is that? Because what we have done right now, if you look over here, what happened is that if you simply follow the commands and took you like to NVIDIA website and everything is fine, so why do we still miss something? Well, because you have to pay attention over here. It says cuDNN version 8. What version is this? This is not version 8. Most of the time people will just click. Oh, it's not working. It's not working because this is not the version that they have recommended. They clearly say version 8. So now what I need to do, I need to go back here and search for cuDNN version 8 download. Okay? And that's what I'm going to do. Okay, the CUD archive, it will show me all the previous versions, from which the first one is cuDNN version 8.9.7, which will do, and it's for CUDA 12.x. Remember we installed CUDA 12.1? So this will definitely work with my CUDA 12.1. And it is version 8 as they require over here. So download this, and it says local installer for Windows. Click, you get a zip file. Okay. So now what I do is that go back to the folder where I've downloaded this cuDNN version 8. I right click on it to unzip it using 7zip. I will unzip it over here. Okay, and just wait for the file to be unzipped. So now that we have extracted this cuDNN, open it. You will see 3 folders inside of that: the bin, include, and lib. What you need to do over here, you need to copy the content of these folders to the same folders from the installation of NVIDIA CUDA. So for each one of these, this is the bin. Select all the files, copy these, go to your C drive, go to your program files, okay, and then you have your NVIDIA cuDNN, version 12, that's the closest to what we have. Replace these files because I had them already over there. Go back to my downloads, get the other one, include, go back. Okay, so this is the include, again 12.6. Replace these files. Okay, and then you still have one more, which is the library or the lib x64. Okay, you go back to the lib, version 12.6, 64, paste it over here, continue because you need admin admission, like permission, sorry, and then you should be up and ready in terms of the CUDA requirements. So now I have all the CUDA requirements, theoretically. Okay, I can check what else is there. And by the way, now for the CUDA+, this will actually let you go up and running like quickly. So even that we didn't have CUDA+ for Windows, because what CUDA+ is doing is replacing some DLL files as well and putting it in Windows 32. So there's another way to install the files, the missing files. Okay, but you don't have to go through that right now because I'll show you how this should be enough for you to go up and running very quickly. So now the last step remaining is that we have basically installed FFmpeg and installed the NVIDIA libraries. We said we need Torch, but beside the Torch, actually, you know what? Let's git clone this. So go back to the NVIDIA command, Anaconda command prompt. So let's go to the folder that I've created earlier in my C drive. So that's c/temp. cd c/temp, and that's my temp folder. I'm going to git clone this repo. Okay. Cloning the repo right now. I'm going to do a dir to make sure it's there. So I had Whisper S2T from another video. Now here's the faster Whisper that we just cloned. So I'm gonna say cd faster Whisper. I'm inside that. I'll say pip install -r requirements.txt. This should install most of the requirements defined in that requirements.txt file. Hopefully we don't have any issues with any of the libraries because this is a virtual environment, so everything should be contained over here. So up to this point, everything seems to have installed normally, no issues. Go back to the GitHub repo for faster Whisper and look for the command to install the library itself. So all what we have done was to install prerequisite and the requirements. Now I'm going to install the actual faster Whisper library. So pip install faster Whisper. Should be going quickly. Finished. So now theoretically we should be ready. However, you might face an issue, which I'm going to tell you about in a while. Let me start the Anaconda Navigator. I typically follow this approach, starting the Anaconda Navigator, installing Spyder, so I can put breakpoints if I need to and have a look at the code, track the functions, and read the source code and everything. So starting Anaconda Navigator, which seems to be up and running. Okay, now we can see that we have the base environment, faster Whisper, which we just installed, and a previous environment that I had from another video. So I'm going to select the faster Whisper. Okay, and I'm going to install Spyder inside the faster Whisper. I'm going to come over here. I'm going to say, this is Spyder, install. So now Spyder is available. Now we can launch Spyder. So now Spyder is up and running. Can go back to the GitHub repo to see the usage example. I'm going to copy this example. Going to bring it over here. Paste it. And this is the code that we are going to run. But before that, let's just have a look. It says from faster Whisper, import Whisper model. That's fine. The model size is large v3. Now this is by itself a few gigabytes of data, so I'm not going to download the large v3. I'm going to go with the smallest version. So small should be enough for my current. So now that everything seems ready, I'm going to test1 file. I have a couple of files in this folder, the temp folder. Let me start with actually my own rocket versus mini rocket mp3. So I converted one of my own videos from YouTube to mp3 using some available tools on the internet. I'm going to save this file. Let's say, what do I call it? Called Faster Whisper. Okay. And instead of audio.mp3, I'm going to put my own file, and this is in the c/temp folder. So as you can see over here, we're importing the Whisper model from Faster Whisper library we just installed. We have the model size, which is the small. We defined that the device we need to run on is CUDA, so we are going to run it on GPU, and the compute type is float16. Then what you have to do is just say model transcribe this file, and this is the beam size what we had talked about earlier. Okay, and some other parameters. Let me run this. Let's see if it works. So there's something wrong over here because it says invalid. It can't see the file for some reason. Let's see if this will help fix the problem. There you go. It started transcribing. And it's printing the content for me. Nice. Didn't take much time. Let me stop this. One of the main things that you may face on your own laptop, you could have an error over here, say like one of the DLL files is missing for NVIDIA. In that case, if that happens, you have to go back to the environment variables again, and you have to go to the system variables, the path, edit, and then you have to add the address for the NVIDIA cuDNN library, for the bin library specifically, into your system variables. Once you do that, you say okay, and close everything and come back over here. This should be working very nicely as it's happening for me. However, if you have noticed, it's actually printing the transcription as it goes forward. I didn't want it to be in this way. I wanted something similar to Whisper. The main reason for that, if you go back to the GitHub repo, so they say over here, while the transcription should be in segments, this segment is actually a generator. So the transcription only starts when you iterate over it. So the way to resolve this issue, you just need to convert the segment into a list. So you say segments equal what? List of segments. Copy this command, bring it over here, put it there. That should be all what you need. I'm going to take the remaining. I don't need it. Now let's start doing some benchmarking. So import time. Okay, I only need to let's say benchmark the transcription process. So let's say start equal time.time, and I did this. Then end equal time.time, and give me a nice print command. Should be an F statement on a new line. Tell me time for transcription equals end minus start, and this is going to print the exact amount taken to transcribe our file. Let's have a try. This should be running smoothly, and I can also inspect my task manager. For this reason, I can see something is happening on the CUDA side. It's actually working, but it's taken some time. Let's wait and see how much time it will take overall. Because in the other video for Whisper S2T, we have benchmark Whisper S2T on the same video. It was taken roughly around, I think, 40 seconds or something like that. Let's see how much time will this faster Whisper take. So now that the process has finished transcribing, so You remember how fast it was when we just got the segments, the iterator? Getting the iterator is a very quick process, but converting the iterator into a list so we can see all the sections text, it takes some time. And in this case, it took us 80 seconds. So Whisper S2T that we have benchmarked previously in an earlier video, you can go and watch that. It took us around 40 seconds. And Faster Whisper has taken around 80 seconds. So what is going on? Why do we have so much time spent on transcription? And this is called Faster Whisper. How is it faster if Whisper S2T is doing it in half of that time? Well, the reason is, go back to the GitHub repo, read more about the instructions you can see over here. And if you continue looking, you will see that one of the commands that we mentioned in the beginning of this video is condition of the previous text. If you do this, by default is on or true. If you keep it on, it means for every segment of audio that you are going to transcribe, you will rely on the transcription of all the previous segments. Now, because my video is large video made of like 40 something minutes, this can take actually quite some time. So what we need to do, comma, okay, turn this condition on previous text to false, and then repeat the process again. Let's see how much time it's going to take now. Put back the task manager. Let's see what's going on. I like to view the task manager. It is doing something again. Okay. Can wait for it, but hopefully that this time should be much smaller than 80 seconds, the overall transcription time. So now it has finished. It took us only 63 seconds to generate the text transcription, which is not close to the 40 seconds that I mentioned. However, in my previous video for Whisper S2T, I was actually using the small model with a compute type of what? Integer 8, not float 16, to be fair for the comparison. So in this case, I'm going to run it again. And let's see if this time we are going to see faster performance from Faster Whisper against Whisper S2T. So it's not much different. Actually, it went a little bit higher. Maybe Windows is busy doing something in the background. But to make sure, let's close this and start the code again and see how much memory, because maybe some memory or something was happening because of the previous runs. Let me just test it again. Still the same thing, around 60 something seconds, which is not bad overall. So if I want to go to the temp folder, or the temp folder, have a look at this rocket versus mini rocket video that I have. The overall length is like 42 minutes and 55 seconds. So 42 minutes, 55 seconds, we are actually transcribing this in 60 seconds, which means 1 minute only. So 1 out of 42. That is how much time it took us to generate the transcription for the entire video. Now if I go back here, where's the output? The output is in segments. And each segment will give you actually a bit of the code. So this one is just saying hello everyone, and and so on. You can print everything that has been said. So again, come back to the Faster Whisper repo. Okay. Go down. I'm not gonna print the code myself. I'm just gonna copy and paste, the lazy approach. There you go. So for every segment, you will get where it started, where it finished, and what was said and that during that segment, and so on. So this is the transcription. Now, one more thing we can do, we can change the model. So the beauty of this Faster Whisper, I've read somewhere here that it also works with the distilled version of Whisper. So the distilled Whisper checkpoints are compatible with Faster Whisper package. In particular, the latest Distill Large v3, it works nicely. So what I'm going to do, instead of saying small, I'm going to actually pick distilled version of small. And this should be EN, I think. Let's see if this is going to work. Small.en. I think this is how it should be. But anyway, let's try. Close. Rerun everything. It should complain if I wrote the model size wrong. Should tell me it's not available in the list of model sizes. It seems to be working. So that still is a quantized version. Much faster. So let's try this, see how much time it's going to take in comparison to the 60 seconds something for the smaller version, or small. This is still small. Hopefully it will take less time. Interesting. Now you can see some decent numbers over there. Time for transcription is only 40 seconds. So the model size is still small. I'm running on CUDA. And the compute type is integer 8, and this is my file, which was like around 42 minutes, and now it's taken me 40 seconds, not even a minute, slightly more than half a minute, okay, to transcribe the entire video for you, the entire audio, sorry. And if you want to see the transcripts, like in the different segments, here you go. These are all of them. And the first one says what? Hello everyone, today we'll be talking about random convolution. Let's actually hear it to make sure. This is audio. Hello everyone. Today we will be talking about random convolutional kernels for time series classification. Correct. So it is doing a good job. And yeah, that's about it. So what you can do over here now, go change the different version of the models, try different models, try the large V3, it's like few gigs, so you have to wait for it to download. Try to run it on CUDA and on CPU. Actually, you know what? You know how we said on this specific setting it took us 40 seconds on CUDA? Let's switch to CPU and see how much time does it take on a CPU using the same exact settings. I only change of like, instead of running on GPU, let's running on CPU. So now you can see that what took us between 40 to 60 seconds on GPU, it's taken actually around 158 seconds on CPU to transcribe the whole 42 minutes of audio. So great performance actually from this library overall. Now what I'm interested in is that since I have another environment, can I actually start the other environment, conda inv list. We said we had a whisper s2t, so how about we activate that? Conda activate whisper s2t. From this one, can we actually start another instance of Spyder? New instance. Let's see if we can do that. Ah, there you go. So now the other instance is actually in whisper s2t. Okay, you know how it was taken from 40 to 60 to run on CUDA over here? Okay, we know it's taken 40 to 60. Let's go back to the other environment, which is whisper s2t. Let's keep it on CUDA, select integer 8, select a batch size of 5 just to keep things like fairly close to each other. And this is whisper s2t from the other video I mentioned. This is the small model. We are using ctranslate 2 backend. Let's see how much time does this take to run. So which file is it? Rocket versus mini rocket from the same folder. There you go. Let's see if this will run. I'm interested to see how much time does whisper s2t take in comparison to faster whisper that we just benchmarked. Because maybe Windows is doing something in the background. Because yesterday it gave me around 40 seconds, but how about now? Is it still 40 seconds or is it going to be larger? So GPU is on, is running. Okay. Let's wait for it. Let's see what's going to happen. Oh, time taken for transcription, 23 seconds. And this is Whisper S2T. How good is that? So yeah, seems that there is a like fair comparison between the two. Like these toolboxes, that's why they continuously update these toolboxes, because the competition is very fierce. But right now I would vote for this one, Whisper S2T, in comparison to Faster Whisper. But there's another version of Faster Whisper which is based on exe log compilation, so we can also test that in another video. But for now, we're all good for now. So thank you very much for watching, and I hope you learned something new today. Thank you.